few more theorems. Fundamental theorem of algebra says every function of a polynomial of degree 1 or more has at least one zero. Now, a function defined by a polynomial of degree n has at most n distinct zeros. So for example, like an x to the third polynomial, it can have at most 3 zeros. An x to the fifth polynomial, x to the fifth, so if f of x equals x to the fifth plus x cubed plus 1, because this is a fifth degree polynomial, we can expect that it may have up to 5 zeros. So anyway, if it has less than that, it's because there's some multiplicity, and we're going to talk a little bit about that in just a minute. We're right here, so the number of zeros occurs refer to the multiplicity of the zero. So we have this function, and this function is actually factored out for us, so it's fairly nice. I know that this zero, because if I set x minus 2 equal to 0 and solved, then that's where I get this positive 2. If I set this equal to 0 and solve, that's where you get negative 1. Basically, it's changing the signs. When I set this equal to 0, those give me my zeros. The multiplicity comes from that exponent. That's multiplicity 3. The 0, negative 1 has multiplicity 2. The 0, 5 has a known 1 right there, so it has multiplicity 1. So number 7, we're going to look at an example where we find a function of degree 3 that satisfies having a 0 of 2, a 0 of 4, having multiplicity 2, and then we evaluate that. So let's look at what this means. So we take our function, some function, and we're going to put an a out here to represent some number out front. So we have x minus 2 because it has a 0 of 2. And then it has a 0 of 4, so that's x minus 4. But the 4 has a multiplicity of 2, so that means that has a multiplicity of 2. Now the next thing it tells us is that when we evaluate f at 1, so if we were to evaluate f at 1 right here, that means everywhere there's an x, we're going to plug in a 1. We would have 1 minus 2 and then 1 minus 4 squared. F of 1 equals negative 18 because our problem told us so. So I'll replace that with negative 18. I'm going to have a times 1 minus 2 is negative 1. 1 minus 4 is negative 3 squared. So that's going to be negative 18 is equal to a times negative 1 times 9. I'm going to continue up here. Negative 18 is equal to negative 9a, so we divide both sides by negative 9 because we're trying to figure out what that a is. So a is 2. So our original polynomials, now we need to come back into this original and put 2 in place of our a since we know what that is specifically now. So our solution, and give myself some room up here to list it, would be f of x is equal to a is 2, and then I had x minus 2 right here, and then I had x minus 4 squared. This is a function of degree 3 with real coefficients that satisfies having the 0 of 2 and a 0 of 4 having multiplicity 2. Here's 2 of the x's, and here's 1, so that's where we get 3 total. Alright, so we come to number 8. Find all the complex zeros. So we want to find all the zeros and then give the multiplicity of each zero as necessary. Now because this is a 4th degree, we can expect that there's probably going to be up to 4 zeros. No more than 4, but up to 4 depending on what these things factor out to be. Now, it didn't give me anything to try. It didn't say, is 2 a factor or 2 a 0 of this? It gave me nothing to try. So that means basically I'm way out there in the big pool of things. What I want to do is use our rational theorem to get me into this red zone so I know all my possible. Once I know my possible, then I'm going to use synthetic division to find the ones that truly are zeros and then use those to get my answer. So let me move this out of the way. And I'm going to say plus or minus p over plus or minus q to find out my region in red, so to say. Plus or minus p is going to be all of the factors of this. So everything that multiplies to give me a 4. Well, 4 is 1 times 4 and 2 times 2. So it's going to be plus or minus 1. If I put them in order, I have plus or minus 2 and plus or minus 4. My q comes from the leading coefficient, which is a known 1. And in this case, it's just going to be plus or minus 1, which when I simplify 1 divided by 1, you just get 1. You're just going to get 2. Just going to get 4. So you have plus or minus 1, plus or minus 2, and plus or minus 4. Okay, I'm going to move that information off to the side so we have some room for synthetic division. Okay, so I moved my possible off to the side, and I'm going to start with 1x to the 4th, 1x to the 3rd, negative 9x squared, 11x minus 4. I'm going to set up synthetic division, and I'm just going to start with the first one. I'm going to start with a positive 1. Okay, drop the first term. 1 times 1 is 1. Add down. 1 times 2 is 2. Add down. 1 times negative 7 is negative 7. Add down. And I was fortunate because I did find one of my zeros, so that's nice. That means when I come over here, it's going to be x minus 1, because remember, if it's a positive 1 here, when you put it back in this format, it's a minus 1, times whatever my resulting. If this was an x to the 4th, then this becomes 1 degree less, so it's x to the 3rd, and you keep going in descending order until you get to the end. So x to the 3rd plus 2x squared minus 7x plus 4. Okay, well, I got one of the factors, but this thing still needs to be factored. It is not a x squared, so I can't use bottoms up yet. Basically, I'm just going to have to keep relying over here using synthetic division to find the next one. Let me just try. I started with positive 1. I can start with a negative 1. So I'm going to move this. Alright, I'm now doing synthetic division with this because this is what I'm trying to factor. So 1x cubed, 2x squared, negative 7x plus 4. Let me try, we said a negative 1 this time. We look at negative 1 and we see we did not get a 0 for our remainder. So this is definitely not a 0. So that didn't help me any. I'm going to try, now I'm going to erase it. I'm still looking for a factor of this polynomial. I tried the negative 1, it didn't work, so I'm going to just start here with a positive 2. And we look and see that positive 2 did not get us a 0 right here, so 2 is not a 0. We're going to try negative 2. Oh, it doesn't look like negative 2 is going to work either, so we jump back up here and we're going to try positive 4. Okay, so positive 4 doesn't work either. We only have one left, negative 4, and we're hoping it's a hit because if not, we might run into a little bit of trouble. So let's plug that in. If you needed to pause these to write those down, that's fine. But we're just kind of bringing you through the process. Yay! So negative 4 is a 0 of the polynomial. What that tells us, remember, if this is a minus 4, when we bring it over here, it's a plus 4. I carry this one down from the past, and then I know x plus 4 is a factor. And then if this is an x to the third polynomial, then this is x squared x. So what I have left would be x squared minus 2x plus 1. Now, we said once we got it down to a quadratic, to an x squared, we could do bottoms up. So what multiplies to give us 1 adds to give us a negative 2. So negative 1 and a negative 1, when we multiply them, we get positive 1. When we add these two factors, we get negative 2. It's over a known 1 because the leading coefficient's a known 1, so 1x. Right from the bottom up. So this is going to be x minus 1, x minus 1. I'm going to drop these original ones from the previous steps. And I'm going to look at this. This 0 is going to give me x minus 1, and then I have x plus 4. You can see I have 1, 2, 3 of these. So that's going to be to the third power. And I only have one of the x to the 4, so there's like a known 1 here. So our function can be represented with a multiplicity because we found all the zeros of this. So there was the 0 of 1 has multiplicity of 3, and the 0 negative 4 has multiplicity of a known 1.